Hello, hi everyone. I'm Saber from KX. I am a senior venture capitalist at KX, and I think today I'll share with you a few things that we have. I think one of the topic that we have today is about how really to fail fast, how we apply this same paradigm in KX, and would like to share with you a few things. So I have a few video here for you to view. So yeah. So I guess what I'm sharing with you, there is a sound here, but what I'm sharing with you is that there is a concept that when you're building products, you will assume there is a lot of failure. And we attribute that to everywhere in our development cycle. So try to optimize what we build and try to make sure that we also do sustainable. So one of the idea that we have is basically from, I think, one of the biggest rocket company in the world, that is from SpaceX. And what we're doing is that we're actually trying to analyze how did they actually was able to achieve such redundancy and how much they failed too many times in order to achieve how to land it like with AI, I would say. So yeah, as you can see here, there is a lot of things, a lot of debris, and this is the exact same typical what we do. So I'll jump in right quick. So 2 years later, with all these failure, we have like 2 rockets, not 1. So the exact same thing that we try to iterate as much as we can. We try to build a better product every time we fail. So yeah, so all right, so enough about rockets. And what I want to share with you is like, who am I? So I am Saber, working at KX, and I'm helping to basically build up a brand new generation of application and bring that to our development life cycle with rapid prototyping iteration to help build up how actually things works at SpaceX. So yeah, so what basically our goal was pretty much is to really emphasize a few things that how we define the goal at KX, how we actually make sure that when we are developing our products, it's 100% reliable and reusable in the large scale. So we use a very variety of application for that, and we want the very first item that we listed out is that to understand our data. So one of the key thing that we implemented is really we tried to understand how our data really is structured in our database. So from that point of view, we tried to build up the structure that we want eventually for our application. The other aspect that we really look into was the design and how we design our application. And the last part of it is how do we approach such application, such building. So yeah, I'll jump in really quick. So basically here, when we define is that what actually was our goal is that we wanted really to, pretty simple, but we wanted to build a platform that is the same time it's scalable and the same time is performance, and we can tweak it and we can change it at any point of time. It was after rapid iteration that we were able to do so. So I'll share with you here a few things that we have. So I think if we are looking, what we started with, we started looking at our database. So we started looking to how we're structuring things, how we actually having rows and columns, and how we address that. And basically that, if I can share that with you, is pretty much looks like this. So the data was pretty much humongous in that sense. So we tried to organize and we tried to approach it in a very different way. And after that, we actually went further than that, and we tried to use AI to understand actually what we're trying to rebuild. And the very exact same thing, it actually tells you exactly how much is wired up. So we have a lot of data there that it was spread around. And after that, if we take a look back, this is 3D modeling for it. And if you look back, and then we can see actually how actually AI are reading that. So we wanted to organize our data typically by reasoning, by trying to understand what we're trying to build. So to put this for you in context, I think in numbers, so currently at KX we run about we failed too many times. We had pretty much approached it like roughly we were trying to build about microservices. We have about 73 where we're building an app. And every time we fail, we try to make it better every time we fail. So the very same thing that these failures, these numbers are coming, is that we have a lot of things that we did over the time. So we can characterize that into 3 parts. So we have a data layer, an application layer, and a front end. So I'll share with you a few things, that the challenges that we had. Building this thing wasn't that easy. So we have a lot of open source, a lot of open source projects in our project that we're trying to get rid of. We're trying to remove them. We're trying to replace them. We have also a little bit of encryption that was not that fast as we hoped, and we tried to optimize that. We looked into the WebSocket, and we have a very less kind of RFC compatibility. And the same thing we're trying to address is that these are one of the problems that we did, and we're trying to optimize them as we go. So the key thing to do so is to go beyond that. And I'll explain to you how we did that in application layer here. And this is how it looked like, maybe our backend stack. So we had a front end, and this is, I would call it API. And what we tried to do is we tried to simplify it as much as we can. So we don't have any APIs. We have less kind of wiring that we need to do. It's pretty much the entire backend is fully event-driven. So we're trying basically to optimize as much as we can. And to move beyond than that is that we try to accomplish something it was not possible in a normal paradigm, in a normal development. So we built up 2 layers, gRPC and HTTP, the same layer. We didn't have to have any complex. We tried to build it in a way that actually very simplified. So we share up the both layers at the same time. So as you can see here, we have pretty much a lot of layers under one application that we have developed internally in-house, and we're trying to optimize what we're building at the same time. Okay, so if we look to our application at the very initial stuff, here's where it's looking. So it's a bunch of nodes, and they're talking to each other. And we're trying basically to reduce how much the frequency. So in that sense, mostly is that if you zoom in a little bit, you can see a little bit of services that we use it. And this graph allows us to see what is the data flow, how is the data reacting from database and onward. So we try to reduce as much as we can by understanding what we have as an application. So moving from that graph is we were able to establish things like metrics. So we will be able to address few things at the same time. We'll be looking to the latencies, and we're looking to the dependency over the course of the time. So to reduce how much, and we try to find every piece that where we can improve. And now I'll jump into the data layer. So conventional database, it will look like something like this. So what we really try to do is try to change this thing, and we try to make it better in a way that we can access the data. So normally the data is laid out in such a manner as well. And what we try to do is that we changed it this way. So we have a couple layers here. So to begin with, that we are running all of these. I'll explain to it in a better time. So we have basically at the top the query router, and what we try to do is we try every request that is entering, we try to optimize it as we go. So we try to define the operation that is happening and try to reduce the latency. The other 3 layers are in database. So we were trying to execute the enclave of encryption of blockchain wallets and try to introduce them at the database sides, but not at the API side. So this is one of the things that we tried to reduce in terms like query. So we weren't sure about how we distribute that and how to optimize to unpack all that data. Yeah. So what we win from this is we were able to establish basically a 0 type in that sense of dependency. We reduce also to how many code gen that we need to do every time, and we try to approach that every time we're solving solution in that sense. So there is a lot of items that we get out of this is that we try to change the data model on the fly instead of having it running in the database. So that's one of the things that we try to achieve in that sense. Yeah. So I'll jump in now to the front end. So from the front end point of view, we use a little bit few tags here that we have. So we use pretty much NX and Next in that sense. And what we try to do is try to optimize most of our layers. So you can see we have two apps. They run shared across the same time. And we're trying to diversify and share the library between each of them. So this is to optimize the process. And if you can see, when we are using one library, one app, and try to use the same exact library, and when we share with the other thing, we just simply, it shows up the other app at the same time. So what we try to reduce here is the impact that could have in terms of database overall. Yeah. So if we wrapped up all together, so this is what we come up with. And we try to address that in a many point of view. Is if we lay it out this way, we could understand better our apps and try to minimize each one of it. So other tools that we used in this is basically Codana, Deep Source, and CPress all together that in our pipeline to optimize what we actually build up. Yeah. So jumping up to the stats that we have, clearly is that we have roughly about 28 Next.js app, one workspace, 7 build configuration, and pretty much like we have 52 entirely shared components in at the same time. So the question here is how we deploy these. So we had pretty much optimized the process how we're deploying all these apps and designing them up. So basically we're using the ingress and endpoint slice and the deployment to roll up all of these apps. Yeah? And it comes to routing. So in terms of routing, so we basically, we were addressing each route and we distributing for each route, we have its own app. And what we did is that we're trying to split what is the code execution and the deployment time. So we can deploy anytime both of these apps or individually or either way, we can do that in that sense. Yeah. So yeah. So all of that, it comes up that we actually achieved such performance. And all of this technology that we use and we built in-house, it allows us to achieve such performance that we can highlight to you here. The other part is that how all of this functioning is actually, we design the data layer, we push that to the front end, we add in the business logic, and then which says event-driven architecture all the way, all time. Yeah. Okay, so in terms of team, how we operate inside, we actually have a design team, UI team, backend team, and then infra team. And all of them working up together to help address actually the efficiency. So we have less micromanagement. We have a very flat organization where we can actually, each one of us, contribute to it. So, yeah. Final thoughts that we have in that sense that the key takeaways from this is that we separated most of the apps. We had a shared library across, and we also trying to build up a composable component where we can actually split out and divide our application and help make it in a sense that is much more usable. And we also to attend the performance that we actually desire. Yeah? So final thoughts for this before we end it. So I think there is a key takeaway from this is that we automated most of our process. We try to streamline throughout all these applications that we have. We try to design it and make sure that we have a different approach for each, and we try actually to build like a reusable code at the same time. So with that, in that sense, if you cannot find the right tool, we just build it in that sense. The other aspect of this is I think all of these things comes together with the team that we have. We have very talented people at KX. We also have a very desirable team that we are operating in a very easy fashion. We had less communication, so the team is the key thing to this. So yeah, thank for the team. The other thing is that we do have a research. So we run our own research R&D inside KX to help optimize what we actually build, and we try also to empower the developers we have so that they can actually upskill themselves. The other thing is motivation too. So when we actually in KX, we really think to build a good product. And with that is that we try to do not just only like the first, we try to beat that every time. So every time that we have a progress or we made application performance, so we try to address that and we try to resolve that. The other last item that I have for you is the approach. So when we're designing, we actually have a full different approach for each, and we try to build up all together, all these things together to build up our team at KX. And we did have accomplished this, and we want to share with you what we actually have accomplished so far. So, yeah, thank you guys.